Good morning, class. We'll continue with part 4 of the lecture for chapter 3 selection. So far, we already covered on random integers, random numbers, if, else, if statement, the common errors. Now we'll continue with logical operators. Okay, so this one. Okay, the truth table for operator not and or operators. Okay, we have used conditional statement to help us to determine if the execution should take one path or another path. Okay, true path or false, whether it's a true or false. But until now, these conditional statements have been very basic. Usually, whether a statement is executed is determined by a combination of several conditions. You can use logical operators and combine these conditions to form compound Boolean expression. Let's see, logical operators are also known as Boolean operators. Operate Boolean values to create new Boolean value. So the following slide shows you three logical operators we will use. Okay, let's see. We'll use not and or. So not means logical negation, logical conjunction, or is logical disjunction. Okay, these are some basic description. We only need to know the major part, the operators. Okay, the truth table operator not. P is true means not P is false. P is false means not P is true. Assume that age is 24, gender is female. Okay, uh, not age is greater than 18 is false because age is greater than 18 is true. Not gender equal to M is true because gender M is false. Because here the gender M is false means it's go to female F. Okay, the truth table for operator not examples. Not true means it will give you false. Not, is it correct? They're asking 20 is greater than 16. True. So this one is false. Okay, this one is false. So not false means it's true. Okay, 60 is greater than third one. 60 is greater than 20. It's true. But when they say not true, so it's a false statement. So there's a double not. The next line, quote number 4. So not true is considered. Not true means it's a false. Not false means it's a true. So we have okay, this one based on the brackets. But the last one you can see there's no any bracket. So we'll check not false first and then overall false. Okay, not false is true. Not true is false. So this is the truth table. The truth table for operator and okay, this one we already learned in school. I guess I hope you guys remember this or recall back. Okay, if P1 is false, P2 is false. When it comes to AND operator, both conditions must be true. Then only your final output is true. Okay, false, 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 true, false. Because one true, one false means still go for false because it's an AND operator. AND operator means both sides must be true, true. Okay, if one false, one true means it will be false. True, false, false, true, true is true. Okay, so we have three false and one true for the AND operator. Next, okay, this is an example for the AND operator. True and false and true and false. So they will check true and false. False the answer. So not false first is true. True and true is equal to true. Not true is false. Not false is true. True and 10 is greater than 20. False. So the answer is false. Third one, huh? Fourth one, the answer is true. So you guys can go through lah. This example is quite very basic one, so I don't want to touch on by one. Next, we'll go with the OR operator. Okay, for the OR operator, either one condition, condition one, condition two, either one is true, okay, is enough for it. So false, false, we'll get false. False, true, 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 false, true, 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 we got true. So in this case, we got three true. So for AND operator, we got three false, one true. But when it comes to OR operator, we got three true, one false. So that is the difference. Okay, so these are the example. You guys can go through it. Let's write a program to test the Boolean operators. Okay, write a program that tests the usage of Boolean operators. Specifically, a program should prompt the user enter one integer. Your program should determine if the value is divisible by 2 and 3, or by 2 or 3, or by 2 or 3, but not both. Okay, so I guess we're going to have like three conditions. Okay, so problem solving. So we're going to check modulus. So example, if x divisible by 3 equal to 0, okay, this says that we divide by 3, the remainder is 0. And this is exactly what we want. And we must check the divisibility of two numbers, both 2 and 3, if divisible by 2. And I say divisible means the remainder is 0. Okay, and the logical operator and should be used over here. So design your algorithm. So this will be your algorithm. User enter the number. If the number is divisible by 2 and divisible by 3, then it should print. Okay, the number entered by user is divisible by 2 and 3. If the number is divisible by 2 or divisible by 3, they can say that it's divisible by 2 or 3, either one. Okay, the last one, if the number is divisible by 2 or number is divisible by 3 and not by both, right? So that's the reason they say number entered by user is divisible by 2 or 3 but not both. They are not divisible by both numbers, either one. So this is your coding. So enter user input, first if statement, second if statement, and third if statement, lastly print statement. This one you can write in if else if statement as well. Okay, so this is the De Morgan's law. I don't want to touch on this. Okay, this is the additional notes I got. I hope you guys can go through. Uh, okay, Boolean expression. Number greater or equal to x and number less than y can be simplified by using equivalent operators, equivalent expressions. X less than equal to number is less than y. The following Boolean expression not equal and equal. This one is not equal to x, this one is equal to y. Can be simplified by using equivalent operator. Okay. Instead of using and statements, we use equivalent expression. Okay. First, x, assume that x is 1. Show the result of the following Boolean. So true and 3 is greater than 4. This one is true. This one is false. So 1 true, 1 false, you get false because AND operator, not x greater than 0 and x greater than 0, it's false again. Number 3, x greater than 0 or x less than 0, either one is true. So what is the x value here? X is 1. 1 is greater than 0? No. 1 is less than 0? No. So 1 is greater than 0, which is true. Number 4, x not equal to 0. 1 is not equal to 0, correct? X equal to 0. Okay, so this one is false, this one is true. Number 5, x greater than or equal to 0. So 1 is greater than or equal to 0, yes. X less than 0. So one true condition, so we got true. X not equal to 1 and not x equal to 1. So this will be true. So one false, another one also false. We'll get true. Write a Boolean expression that evaluates to true if variable num is between 1 and 100. Solution: the num should be less or equal to 100 and greater than or equal to 1, or equivalent to number is greater or equal to 1. You can separate. Okay, this one like single, this one is like separate 1 1. Okay, so you can write in both way, so it's still considered both are correct answer. Assuming x equal to 4, y equal to 5, show the result of the following expression. So y, so in this case, y is 5, 4. So 4 is greater than 5, 4 is greater than 5, 5 is greater than 0. So this one is true, this one is false. So the answer is false. Okay, the next case, 4 uh, y. 5 is equal or greater than 4. So it's true. And y is greater or equal to 0. Y is 5. Also true. So to get true, x not equal to y and y is equal to 5. So y not equal to x means y equal to x not equal to x means y is 5, x equal to 4, so both are not equal. So one is true, another one is true, so we got true. The last one, x not equal to 0 or x equal to 0. So this condition is true, this one is false, so we'll get true because the or statement. Okay, so Boolean expression for the true if the age is greater than 13 or less than 18. So you can write first method, second method, both are same. Write a Boolean expression true if the weight is greater than 50 or height is greater than 160. So you can use weight is greater than 15 or height is greater than 150. Okay, write a Boolean expression. Okay, previously it's an OR statement. The same thing is applied and operator statement, logical operator, and this one is and not operator. Okay, so that's all for the Boolean expressions, the logical operators, not and or statement. Thank you, class.